We are living right in the middle of a completely mind-bending AI boom. It feels like new, unbelievably powerful models are dropping every single week. But here's the thing. Behind this explosion of intelligence, there's a hidden price tag, and it's one that's measured in energy, in money, and ultimately in power. Today, we're going to break down that bill. And if you want to get a sense of just how big this is, listen to NVIDIA's CEO. He's not just talking about software or code. No, he's describing a physical overhaul of our world, a whole new foundation being built from massive data centers and billions of microchips. I mean, this is a revolution you can literally measure in concrete and steel. So that really makes you wonder, right? As we're all celebrating the incredible, almost magical power of AI, what's the actual price of all this progress? Because the costs are stacking up, and they're often in places we're not even looking. All right, so let's start with the boom itself. We're in what some people are calling a Cambrian explosion for AI. It's this moment of sudden, massive diversification, kind of like what happened with life on Earth millions of years ago. The pace of innovation is just staggering, especially in the open source world where this global community is building some of the most powerful tools on the planet. I mean, just look at the capabilities that are popping up. We're talking about models that can put elite GPT-4 level intelligence right on your personal laptop. We've got others that can analyze millions of words at once. That's like reading an entire library in a single glance. And now some are being built with over 1 trillion parameters, a scale that was just science fiction a few years ago. The very definition of what a powerful AI even is, it's being rewritten right before our eyes. And what this means is the game is completely changing. For years, the best AI was locked away inside a few tech giants, right? Well, now open source models are just breaking down those walls. They're not just playing catch up anymore. They are pushing the boundaries, allowing anyone, anywhere to run, modify, and build on them. We're literally witnessing the democratization of cutting edge AI. But all this incredible innovation has a cost. And the first item on the bill is the environmental one. The massive infrastructure that's powering this revolution, it's leaving a staggering and, frankly, a rapidly growing footprint on our planet. Okay, so here's the heart of the problem. Just a couple years ago, AI was a tiny little sliver of the energy used in data centers. But by 2028, some forecasts predict it could be responsible for over half of it. That's not just growth, you guys. That's an exponential surge that is putting an absolutely immense strain on our energy grids. And to put that in perspective, some reports project that by 2030, the demand for electricity from AI data centers could be 11 times higher than it was in 2023. This isn't a gentle slope we're talking about. It's a sheer cliff, and it has huge implications for our energy infrastructure. And believe it or not, electricity is just the start. This revolution runs on water, huge amounts of it, just to cool the data centers. It demands more raw materials for chips, it drives up emissions, and this is leading to real-world conflicts. Local communities are starting to push back against new data centers that are sucking up their land, their water, and their energy resources. Okay, now for the next part of the bill. This is the one that's causing shockwaves in boardrooms everywhere. The financial cost. See, it's one thing to build a cool AI prototype, but it is a whole other thing to run it at scale. That can lead to some serious sticker shock. This quote just perfectly nails the biggest trap people fall into. A developer can build an awesome little demo for, say, $50 a month. But the second that tool gets into the hands of thousands of real users, that $50 bill can explode into tens of thousands of dollars, and it can feel like it happened overnight. So where is all this cost coming from? Well, it's driven by three main things: how many requests you make, which model you pick, and, this is the big one, token usage. Think of tokens as pieces of words, like linguistic Legos. Every single piece the AI reads or writes has a price, and they add up fast, accounting for about half the total cost. And here's the real kicker. It costs way more to get an answer from an AI than it does to ask it a question in the first place. The model's response, the output tokens, can be 3, 4, even 5 times more expensive. So AI models that talk too much aren't just annoying, they are incredibly expensive. So, okay, the bill is huge, both for the planet and for the wallet. But the story doesn't end there. Teams are getting way smarter about how they use AI. They're developing these really clever strategies to tame the costs without sacrificing the amazing results. And it really boils down to 3 smart strategies. First, you've got semantic caching. That's basically just giving the AI a memory so you don't have to pay for the same answer over and over again. Next is intelligent routing, which just means using a cheap, simple AI for easy tasks and saving the expensive powerhouse model for the heavy lifting. And finally, prompt optimization, which can be as simple as telling the AI, hey, be concise. Shorter answers means smaller bills. It's that simple. And check this out. This is why caching is such a no-brainer. Research shows that nearly a third of all questions asked in a business setting are just rephrased versions of something that was asked before. If you cache those answers, you get an instant, massive saving with absolutely zero loss in quality. This builds right on that idea of intelligent routing. It's all about using the right tool for the job. You wouldn't use a powerful frontier model for a simple task, right? That's like using a sledgehammer to crack a nut. If you need speed, you use an optimized model. If you need privacy, you use a self-hosted one. It's about being strategic, not just defaulting to the most powerful thing you can find. So, we have the tools to make AI smarter and cheaper and more efficient. But even with all those solutions, a much, much bigger question remains. Who is all this efficiency actually serving? And that brings us to the final and maybe the most important part of the bill, the one about power. Because let's be real, this isn't just about cool tech. It's about power. When you build the largest infrastructure in human history, the people who own it and control it, well, they have an enormous amount of influence over society, over politics, and over our daily lives. So who's actually in the driver's seat? As we look to the future, there are really two very different paths emerging. On one side, you have the vision of centralized monopoly control. It's driven by profit, and our data is treated like a private resource to be mined. But there's another vision, technology for the common good, one that's democratically controlled, designed to meet real social and ecological needs, runs on renewables, and treats data as a public good. And the stakes for getting this wrong? They are incredibly high. Concentrating all this power in just a few hands creates some really serious risks. We're talking about spreading misinformation at a scale we've never seen before, intensifying surveillance, undermining creative work, and just steamrolling local communities. These are fundamental threats to a healthy democracy. So it all comes down to this. The future of AI isn't some distant sci-fi concept. Its foundations are being poured right now, in data centers, in boardrooms, and in lines of code. The crucial question for all of us is who gets to decide what that future is actually going to look like?